Just like all the other parts in the Titan rocket series, this is a turned part that you're going to make on a lathe. And because of that, we're going to actually put a theoretical line bisecting this part in half, and all of our measurements are going to be radial measurements off of that. So let's take a look at the blueprint. First thing that we have is we have our front view. Says that the overall outside diameter is 950 thousandths, and then we have a 830 thousandths kind of like a shoulder on this side of it. We have a section view going from C to C. We see that right down below as we have section CC. To the right of it we have our right view, and there's some clarification that we have a couple radiuses in here, and then we also have a chamfer there. In addition, we have detail A, which gives us some clarification on some of our thread reliefs and then also the major diameter of our threads. In our section CC, this is where pretty much all of our measurements kind of reside in to make this part. To the left, we have our isometric view, including a detail B. Detail B is here to kind of dictate what the major, minor, and pitch diameters are calling out for. Up above we have our external data section, and this information is derived from the Machinist Handbook. So let's dive into Fusion 360 and make this part. I'm over here in Fusion 360 right now, and very first thing that we're going to do to anchor this part is we're going to draw a line. This particular line is going to be the overall length of our part, which is 1 inch 300 thousandths. I'm going to zoom in there, and I'm going to drag this down a little bit. Right now, all I'm going to do is kind of sketch the outside profile of this part. So this section here is going to be our threads. Here's our thread relief, kind of like this. We have the shaft. We have this kind of V-shaped shoulder here. Doesn't need to be perfect, just kind of a rough geometry of what this part's going to look like. Next thing we're going to do is we're going to jump over into the dimension mode. We're going to add some dimensions to this. From this point to this point is 200 thousandths. From this point to the bottom of our V here is 300 thousandths. From this point to the end of our shoulder is 500 thousandths. Forgot one measurement. From this point to this point is 460 thousandths. Oops. From our datum over to our thread relief is 935 thousandths. From there here to the back side of our threads is 1 inch. And then I'm going to take a little bit of time, kind of clean up my workspace so I can see these a little bit better. Some of these measurements got kind of jumbled up on each other. There we go. Okay, so notice by just adding those measurements in, our part is actually kind of taking shape. It's looking almost just like the print now. We're going to add in our radial measurements now. According to the print, this is 415 thousandths. From here to here, this is 315. Here to here, 475. This one is 500 thousandths. We're going to divide that by 2. Oops. And for whatever reason, it doesn't like that measurement. 500 thousandths. We're going to divide it by 2. I think what's happening is the part is over constrained right now. Just try typing that in. Yeah, so one of these constraints over here is causing it to act all goofy. So let's drag this in a little bit. See if that helps. There it goes. So this thread relief here, this diameter, was causing this measurement not to be able to be entered. So fix that one. Now we're going to measure that one. This one is 260 thousandths divided by 2. And then the major diameter of our thread is 366 divided that by 2. Just like before, I'm going to organize my workspace a little bit. Kind of drag these measurements around so I can see them at a glance. Drag this one in here. Just like that. Okay, ready to revolve the part. Go to solid, down to revolve. This is our axis. And here's our solid body. Right now what we're going to do is we're going to add in some of our missing fillets. Modify down to fillet. First one that we're going to look at is there's a fillet right down here in the corner. And on the print it says 4 times 16 thousandths. So that is indicating that there's a fillet here, and there's 4 of them. So we need to count these things out. So I'm assuming that obviously this one is 1. It appears like there's one down here in this groove. That's 2. And appears like there's one here, 3. And I'm assuming that this is the 4th one here. And I wish they did a better job of clarifying this on the print. This is something that if I was making the print, I would actually change that and add a little bit better clarification. So what we're going to do is we're going to take those. So 1, 2, 3, 4. I'm going to type in 16 thousandths and then OK. Right click, repeat fillet. We're going to add in the thread relief fillets. So those 2 lines there at 20 thousandths max. And then we're going to add in our chamfers. We're going to chamfer this line at 35 thousandths. Oh, didn't like that one for whatever reason. So notice that we're coming up with this error here, and basically what's happening is our previous chamfer, or the previous fillet, is causing it to do that. So let's see if we can add that in first. So chamfer, I'm going to roll my history back forward. It's kind of interesting. Okay. Right click, repeat. Sorry. We're going to have to go back to chamfer because we rolled our history. And then we're going to chamfer these 3 edges here at 10 thousandths at 45 degrees. And then we're going to apply our threads onto this face. Now, these threads here are going to be 3/816 threads. Decimal equivalent of 3/8 is 375 thousandths. Designation is 16 threads per inch. Class 2A. And then we're going to model these threads because I actually want to see them. I don't want just a picture of them. So here's our part. Getting pretty close to being done. Last thing that we need to do is over here on this side, we are actually going to drill and tap a hole. We're going to turn on our origin. I'm going to go to hole. I'm going to click on our origin. Use that as an anchoring point because that's in the exact center of our part. This particular hole, there's no chamfer stated other than break all edges. So we're going to disregard that for this particular hole. What we're going to do, it needs to be tapped, the threads need to be offset, and then the hole type is going to be simple. The drill depth, so the overall depth here is going to be 600 thousandths max, so I'm going to go to the max limit, 600. The length of my threads is going to be 350 thousandths, and then they also are specifying that they want you to use a 140 degree included angle drill bit. And these threads are going to be 375 thousandths or 3/8, 3/816, class 2B. And then we are going to model those threads and press enter or OK. And I'm going to turn my origin off there. So this is a good opportunity. Check your part. Make sure that you got everything off the print onto your part. And this concludes making the Titan 91L.